Forking versus cloning. Both duplicate Git repositories, so what's the difference and why does it matter? In this video, we'll use motion graphics to learn the theory behind these two operations and see actual examples to unlock your understanding. First off, only one of these commands is actually a Git operation, and I'll give you a hint. So if forking isn't even a Git command, what does it actually do and why is it so popular? Well, behind the scenes, the forking operation is actually an umbrella term describing a series of actions, starting with clone. So before we get to those other things, it makes sense to start by understanding the humble clone. Cloning is the process of creating a copy of a Git repository, and the clone operation itself is pretty straightforward. Simply pass it the URL of a Git repository that exists somewhere on the internet, whether that be a hosting service like GitHub or GitLab, your company's intranet, or a friend's private server, and Git will download a copy to your computer. That's about it. Behind the scenes, Git is doing some interesting things during this clone operation. However, those details aren't particularly relevant to the fork versus clone discussion. So if you're curious, check out my dedicated video on clone. Now that we know about clone, let's get back to forking. To talk about forking, we need to mention probably the single largest shift in modern Git workflows. That would be the use of Git hosting services. Services like GitHub or GitLab allow users to store Git repositories in the cloud and offer additional functionality on top of vanilla Git. These additional features can make it easier to work on software projects with collaborators from around the world. And the forking workflow is how these hosting services attempt to make this kind of large-scale collaboration easier. You see, with public open source projects, it's not always feasible to give everyone write permissions to a repository. That type of anarchy can get out of hand pretty quickly. So these repositories cannot be modified directly. Instead, they're managed by a core set of maintainers, and only these admins can modify or approve changes to the repository. So if this Git repository can't be modified directly, how would somebody outside the admin group contribute? I mean, large open source projects sometimes have hundreds of contributors, so there must be a way. The answer is, of course, forks. The forking workflow starts by using gitclone to create a copy of the original repository on the same hosting service as the original. Instead of creating a clone on a computer, both that original repository and this new clone exist entirely in the cloud within our hosting service. This server-side clone is known as a fork, and we can refer to the original repository as the upstream repository. During this forking operation, two important things happened in addition to actually cloning the repository. First, permissions. The forked copy is owned by us. That would be the person who forked the repository, meaning that we have read and write permissions and we can actually modify this copy. Secondly, the hosting service set up a link between the upstream repository and our personal fork. What I mean by link is simply the ability to sync changes between the repositories utilizing their web interface. So if that upstream repository got new changes after you forked it, you can simply click a button and the hosting service will handle fetching and merging those changes into your fork. But what about the other way around? Say you've made changes to your fork and you'd like to merge those changes into the upstream repository. In this case, hosting services have created a mechanism called pull requests or merge requests that take into account write permissions and allow upstream admin groups to review and approve contributions before merging. Pull requests are one way that hosting services enable contributions at scale when it's not feasible to give everyone write permissions to a repository. Now that we know the basics, let's take a step back and look at this entire process. After creating a fork, in order to start contributing, our first step would be to clone that server-side fork to our personal computer. Again, at this point, our forked copy only exists inside the hosting service, so we need to run gitclone to grab a local copy and start working. Now that we have a local clone, we're free to make changes and push those changes back up to our fork. And when we're ready to contribute our changes to the original upstream repository, would tell our hosting service to bundle these changes into a pull request. The pull request would then be sent to the core admin group for review. If the admin group approves our requests, then merge it into the upstream repository. And by the way, if the upstream repository gets updated by other contributors, instead of syncing those updates via your hosting service, you could also pull them locally and push them back into your fork. Pull requests specifically are dependent on your hosting service since they take into account repository write permissions. However, other sync operations provided by your hosting service are typically just wrappers on top of basic Git commands like push, fetch, and merge. So don't feel like you always need to rely on your hosting service to perform these actions. So to recap quickly before moving on to some real life examples, cloning is the Git operation that simply duplicates a repository, and forking is a workflow or series of steps specifically tailored to public open source repositories hosted on places like GitHub or GitLab. In essence, forking exists as a way to enable contributions at scale when a repository needs to be write protected. So when we're talking about forks, all we're really talking about are cloned repositories with a little bit of extra functionality sprinkled on top. Now that we know the theory behind forking and cloning, let's see a quick real-life example. For this example, I'll show both the GitHub and GitLab user interfaces, but if you use another hosting service that supports forking, the process should be fairly similar. I'll start by navigating to the public hosting page on either GitHub or GitLab of the repository I intend to fork. I'm going to look for that fork button, and if you don't see it, make sure you're signed in first. When you click fork, you'll optionally be able to enter some additional information. Remember, this is just a wrapper on top of cloning, so you're able to do things like specify a repository name for your fork. So click create after you're done entering those details, and now you'll have a fork of the repository that exists under your own profile. The hosting service will even show us that this is linked to an upstream repository. Next, I'll want to clone this fork to my local computer to make changes. To do this, I'll start by finding and copying the SSH address of this repository. Next, I'll move over to my terminal, or I can also use an IDE like VS Code and pass it that URL. Executing this clone command will cause Git to create a new directory and extract the source code onto my computer. Cloning via SSH like this requires setting up an SSH key and sharing that key with your hosting service. So if you need help with that part of the process, see this video. After cloning, I can navigate into the new folder and type git status, where we can verify that we have a fully functional clone ready to go. And as you can see in the visuals on the right, this repository is pretty simple and has only 3 commits on the main branch. At this point, we can simply start coding, create a feature branch to isolate your changes, and get to work. After you've been developing for a while, you should have created a couple commits on this new branch, and you'll be ready to merge your feature into main. But hang on a quick second. With forked repositories, it's good practice to leave your changes on that feature branch and instead create a pull request to do the merging for you, instead of manually merging to main. So in order to do that, simply push your local feature branch into your remote fork. That is uploading your local changes into GitHub or GitLab or whatever hosting service you're using. Remember, you can use git remote-v to show you the name and location of the remote counterpart to your local repository. Because we cloned our fork, that origin will be the location of our forked repository. Therefore, to upload our branch, simply run git push-u origin followed by the name of your branch. This uploads our feature branch into our forked copy. But behind the scenes, this git push command also did a bunch of interesting things, and remote branches in general are a fundamental concept in Git, so I would definitely recommend getting more comfortable with them if you're not already. I have a video about that, or you can check out the collaboration theory lessons on my learning platform, learngit.io. Now that your branch exists inside your remote fork, we can hop back into the web interface where our hosting service will have recognized that our fork has new changes. This will typically prompt an option to create a pull request for those changes. Selecting this option will start the process of creating a request to that upstream repository's maintainer group to merge your new changes. Now, this video isn't really about pull requests, but if you'd like me to do a video on what some of these options are and maybe some pull request best practices, let me know in the comments. But from this point on, the process should be pretty straightforward. So to wrap this video up, cloning and forking work together to unlock some useful contribution mechanisms. If you never intend to contribute to open source projects, you might never use forks. But nonetheless, collaboration in general is a fundamental topic. Pushing, fetching, and merging are deep topics that can help you understand a lot about Git. So check out my other videos on the channel or my extensive lesson library on learngit.io to familiarize yourself with any of these concepts. Leave a comment if you have a question, and please subscribe if you made it this far. It really helps me gauge interest in what I do here on YouTube. Anyways, thanks for watching, and I'll see you in the next one.